some textures that might be, this has to be a texture only for iPhone. Or this texture for iPhone should be the iPad version, but scaled in half. There's lots of different ways you can work with all these different assets and not have 4 copies of every single texture. And so I'm going to show exactly how we do that and how that works and why we feel like this is a pretty good solution and what we went with. So the first part of this auto-awesomizer is making this XML, which defines all of the textures in the game and what their compression and how it's scaled down and what the MIP settings are per texture. So you can see here, for example, we have our iPhone section. We have a texture called activate.png, and it's set to a max size of 128. So built into Unity, they have this feature, which is awesome, where you could say, hey, I want this texture, which exists at 2000 by 2000. I want to say its max size should be 128 for this build. So when you build it out, it actually internally compresses that to 128, makes a new asset, puts it into the pipeline. You don't have to deal with an iPhone version of it, and an iPad version, and a PC version. You just have one and some settings for that texture. So that's how that works. The second part is our platform specifics class, which you actually attach to an object and say, I would like a custom position, or a scale, or a custom texture, or a custom font, or a custom text on that font for that object. So I'm going to show exactly how that works. I'm going to show a demo of that in the main menu. So, stop that. Okay, so the simplest way I can show it is in the main menu. So let's go back over here. So here's our starting screen, splash screen. And on the iPhone, there's no level editor. So this button right here just needs to go away when you're building an iPhone build. So how do you do that? We have our platform specifics class right here. So in this case, all we have to do is say, okay, I'd like a restrict platform, and I'd like it to just be standalone only. Done. So at runtime, when the game says, await, it's going to actually delete or destroy this object at runtime.
Actually, what we're doing for the iPhone builds is that we're applying these settings during build time, so that none of the assets that are possibly linked in here, they don't get included in the build at all. So all of these are applied and then taken away, stripped away from the bean to minimize as much as possible. But in standalone, where you can have different aspect ratios and there are a lot of other variables to play with, these are left in the scene so that they can do their job at runtime.
There you go. That's a better explanation of how that works. So yeah, this is pretty simple. We're just destroying this little button right here. Now, the select level button and the credits button, now they're going to be too high, right? Because now you've deleted a button and you had a nice layout and it looked good and it was positioned where you want it. But now you've removed a button. So, and your screen size is going to be tiny on the iPhone. So let's zoom up those button sizes and move them to the right spot. So that's also in this platform specifics class. So for the button I've selected, which is select level, what we're going to do is on iPhone and iPhone Retina, we're going to scale these to the aspect ratio that is 3:2. And we're going to move them down and slightly over. And so what that's going to do is, for the iPhone, it's going to actually move those into the right spot so that we don't have a scene that is main menu for iPhone, a scene that's main menu for iPad. It's just one scene, it's just one set of textures, and then we're doing all this change, as you said, at compile time, right? And also some runtime stuff. So the combination of that makes it very powerful for us. And even stuff in the tutorial where it says, tap the screen to continue, that you can't write that on a PC build, right? It has to say, hit space to continue. So that actual text, we could go in here and say, you know what, I'd like to change the text mesh for standalone to say, press space or something. So it'll override the text that you had on there for the platform. And so when we're running in Brass Monkey on the wireless control, it'll say press activate to continue. So all those changes are happening in this one class, the platform specifics class that we came up with.
In our final section, we're just going to talk about the implications of using having 2D gameplay in a 3D environment. So, as you know, Unity uses a 3D physics engine, which is NVIDIA's physics, to build a physics simulation in the game. And it might seem like if I'm making 2D game, why am I using a 3D engine? This is great for performance. But honestly, the modern physics engines today are so optimized they can handle thousands of cube primitives or cube primitives very easily. For a game like this, unless you're relying heavily on physics, it's going to be no problem at all. So you can put that worry out of your mind. And what you have to do to make the physics play nice in your 2D world is that you have to pretend that your objects are 3D. So Alex, if you could go to the game scene and we can take a look at the truck.
Yep.
So our truck, visually, is just a couple of planes, 2 planes for the wheels, a plane for the truck body. But in the 3D world, it's actually a compound system of colliders, box colliders, that make up a 3D shape for both the front areas and also the cargo section. So if you can go to the perspective you can, and also select the all elements of it. So that's where we keep our passengers in the back of the truck, and they're not all on the same plane as you can see. They're layered in 3 rows of 3 passengers. And the reason for that is when these people go flying into the air, when you hit an obstacle, you want them to be able to get back in without stacking on top of each other so much. So when someone from the second layer gets bumped off, they can get back in because there are only 2 other passengers that they could possibly fly in. Alex, there you go. Just around. And
oh, wait.
You can also see now how our level is made. Graphically, our grounds are just simple planes, but in the physics simulation, everything is a 3D object with some depth to it, so we give some room for things to basically be able to collide with each other. With a 3D engine, you don't want paper-thin colliders. Usually they work, but they can cause problems sometimes, so just give everything a little bit of depth and you'll have a much easier time. You can go back. And another part of this solution for using 3D physics engines is to constrain the movement and the rotation of some of your objects. So our passengers in the back of the truck, the only way we want them to rotate is along the z-axis, so they only can go like this. We don't want them rotating backwards. So what we do is we constrain their rotation. Before Unit 3.1, I believe, this used to be done with what's called a configurable joint, where you can set or limit, lock or limit the rotation of the objects on certain axes. But in the more recent version, they've added this functionality to the rigid body object where you can say, okay, I will lock the movement of this object in the z-axis. So you have the starting position of, it's, let's say at Unit 2 at C, it's never going to move away from that unit. So it's going to be 2 at C. And we actually already talked about that, and you saw the baby come up. The baby also always comes up at the same Z position, so that there is room for those babies to get into the back of the truck as well. And that's our presentation. We would like to have someone play the game while we're taking questions, but are you going to really answer the question?
Yeah.